Alright, today we're going to be talking about how to route a eurorack synthesizer and how some of the fundamentals of it. Pretty much how to get started. And for a eurorack, to build a eurorack synth, you need like a few things. You need a VCO, an envelope generator, ADSR envelope generator, voltage controlled amplifier, and a voltage controlled filter, voltage control oscillator. So those are the four main things that make up a synth sound. And so we're gonna learn today how to route this, and I actually just figured this out myself. So what we're gonna do is we're gonna unpatch this. Yeah, so we're gonna unpatch, and we're gonna start from nothing, and we're gonna hope we remember how to do it. Okay, so we're gonna walk through and explain what all of these four do, and even up here what this does. So in the very beginning, here we have this is your source of where your sounds come from. Not where your sounds come from, where the control comes from. So this could be your keyboard in real life, or this could be a sequencer, and the sequencer would send these two signals into your voltage control oscillator. So what goes where? We have to take the gate and put it into the gate of the envelope generator right here. Then so let's talk about let's talk about what gate is. Gate is it's hard to explain, but gate is like when the signal is turned on and it receives a positive pulse, and until the controller tells it to let go of that electricity, of that signal, pretty much. So what you're doing is you're taking your controller and you're telling it to pretty much turn on and turn off the signal for however long the controller has it. Basically, however long I hold it on my keyboard. And to tell you that I'm not joking, if we like look on my keyboard and I press the keys, the light stays on. If I let go, the light turns off. So that is a control signal that you're sending into your ADSR envelope generator. Okay. So we know what gate does from the controller, and then we're going to send a volt per octave signal into the volt per octave here, input here. And so what we do is we just send it into the input. So the VCO is where the sound, this is the source of the sound, and pretty much we're just controlling what the sound sounds like. So here we have actually, I need to explain this. We have 4 different waves. So a sine wave, a triangle wave, a saw wave, and a square wave. The sine wave is the wave that looks like a hill up and down. And so let's listen to what that sounds like actually, direct into the mixer. And we can put that, so this is a mixer and it just takes in audio and sends it into whatever we're hearing. So we're going to take the sine wave and just put it into here. But nothing is telling the sine wave to like lower volume or whatever. So we're going to have to actually put it into the filter first before it gets into the mixer. So you take your sine wave and you put it into the input of the VCF filter, of the filter here, and then we're going to send the output into the input, into the input of the mixer right here. And so now we have this filter going. As we turn on, as we change the cutoff knob here, you hear less of it as you go down because the sound is being filtered from high frequency to its very lowest frequency. It's literally a filter, a sound filter, a signal filter. Okay. And we can actually see what this looks like visually. So we'll put it into the visualizer. And you see there's more of a sine wave happening here. It's going in that wave format. I'm not sure what this is at the end. That's very weird, but we do see this sine wave happening. And then as we change the knob, we see it more like a bigger sine wave, then smaller, I guess, as you turn the knob to the left. This resonance could be this right here. So if we turn up the cutoff, okay, so the resonance makes the sine wave a little bit more frequent, and we can see how it sounds actually. It sounds higher pitch. So we're just gonna leave it there. So yeah, that's so now we have that, and now, so earlier we sent the gate into the ADSR, and now we have to send this ADSR to trigger the control voltage of our VCA. So this actually goes into here, into the input here, and your envelope goes into your cutoff. So what's happening is the filter is being controlled by the ADSR, and your sound is being controlled or is being sent into the amplifier. Is that correct? See, now I'm getting confused. This goes here, right? Your sine goes into there. Your envelope generator. I'm trying to think what this does. Let's mess with it. I actually just learned this, so if I'm like messing up. So you send the envelope into here, into the control voltage. send this into here, and then what happens? It's almost behaving how I want it to. Okay, I almost got this. Something I'm not doing right. Okay, I know this is correct. So you go from here to here. You take your envelope generator and put it into here. Your envelope goes into the VCA, into the control voltage. Your sine wave goes into the input. Then you take this into the cutoff. Wait, I gotta think about this. The ADSR I would think that the ADSR goes into the filter. I almost got this. Let's see if it works. Yeah, that's it. Okay, so I figured it out. So the ADSR is controlling the amplification. So whatever you're pressing, whatever the ADSR is doing, like pretty much you're taking the gate, you're putting it into the ADSR, and then the ADSR is whatever the sound plays like in this. And then you're taking the output of, that's why you have to send the envelope of the ADSR into the VCA, into the mixer. It's basically a pre-mixer. Then you're taking the output into the filter, and then the filter is fixed. You're taking the output of that and you're putting it into the input. And you can actually take this and put, you can actually take this and put it into here, and then I think it will modulate the cutoff. Without. Interesting. And then when you connect this to the cutoff, and so as you change these levers, you'll have a different sound coming out. So this is pretty cool. So here I did it from concept, how to start out with a eurorack system. We need a VCO, ADSR, a VCA, a VCF. These four things in your eurorack. We're gonna do something more complicated now. And what we're gonna do is we're gonna add in 2 more VCOs to do like polyphony. So we're gonna add in another one. We're gonna make it polyphonic synth. So we're gonna do the same thing here. We're gonna take the octave and put it into here, and then the octave put it into there. And so now we should have seems to be monophonic right now. So we're going to try something. We're going to try using a mixer and splitting the signal. So I want to see if this works. This is all proof of concept, and to be honest, like I don't know if this works. I'm experimenting myself. So this one, what this does is it takes inputs and then sends that out. But I don't think that's what we need. Let me delete. See what else. I just basically need a mixer with multiple outputs, because I'm really like learning myself how to do this. I think this does what I'm trying to do. Okay, so we're just gonna send these signals inside here, just one cable, and then the outputs will go into like these, into like how do you say, like here. Sorry, into here. Oh, that needs to be a different color. There you go. Into that. And we're gonna undo this one and send this one over here. And now it'll be 3 sounds at once. So we're gonna send actually into here. I forgot to do that last time. I forgot to send the wave into here. Let's see what we hear. Still monophonic. Still monophonic. Maybe if I change the signals to like 3 different kinds. Still only hearing like one thing here. Do I need to connect these? Kind of confused now. Okay, we have our 3 waves going in to the mixer, but I'm only hearing 1 channel. These are going actually. Oh, that's why, because we have to send them into here. So they're triggering. Let's see if we can just remove this. And let's go direct. And we might have not even had to have done this. Let's try and go direct into the volts per octave on each one. See if we can skip a signal. It does. It's a very weird behavior. I'm not really sure like what's going on. Only one is getting control voltage. I think I have to connect all 3. Yeah. Okay, but only one is getting. So let's try again going into here, just 1, and then sending them out all 3. So into here, I'm getting so confused. Okay, and then this goes into here, and then this goes into here. Okay, what do we hear now? I can't tell if there's 3 notes. So the notes seem to cancel each other, to be honest, but they're now acting. So I didn't know they all needed to run through the ADSR. I like you can hear them all. Let me see. So the way this is working is actually I only press one note on the keyboard and all three are triggering. Sounds very ugly. I don't like how it sounds. Sounds so bad. Let's try using the cutoff. What? Sounds bad. I feel like it only sounds good with one synth, one oscillator. So let's try it back to one oscillator. That sounds so nice. It really does. Alright, so I pretty much achieved my goal, which was to figure out how to route at least how to route one oscillator properly. I'm good with that. I feel like if you add reverb on this, it's gonna sound really nice. Let's see if there's a reverb here. It's gotta be somewhere. There really isn't a reverb. Come on, I need a reverb. Hold on. Am I just not typing it? I guess there's no reverb. Let's try the delay then. Simple enough. So input goes into here, and then output goes into, where's the output? Right here, right here, right here. And we can send that as well, and then send that into there and into there. Pretty cool delay. tame the signal a little bit. I'm not really hearing a delay. That was cool. There's a delay there. Wow, that's crazy. That's really nice. That's really interesting. Wow. Try a different wave. Try a saw wave. Square wave. Go back to triangle. Interesting. That's pretty interesting. Cool. So that's eurorack, and that's the routing. Yeah, I figured that out. Okay, so VCO, ADSR, VCA, VCF. This program is really used to like test out different scenarios. So I think that was pretty successful. All right, peace out.